Okay, so I was talking about missing data. So it is very important part of, sorry, so I was mute. So I was talking about missing data, and it is very important part of data wrangling activities. Sometimes we get data with very huge number of data, maybe uh, lakhs of rows and dozens of columns, and that comes with many missing values, np values, np.nan values. So those things are present in the overall set, and we don't know how to take this forward to the next level where we'll feed this data to the model for training and for prediction also. So we need to remove all the missing value, and in the process sometimes we delete the rows, sometimes we delete the columns, sometimes we impute the missing values. So all these things are done. So under what circumstances we'll be doing which kind of activities, this is very important. So some common senses are also there that that is taken care of. So let us see some examples here. We have NumPy and pandas we are importing here, and I'm creating a data frame, very a small data frame, and you can see df is the small data frame in which we have rows ranging from 0 to 5, index ranging from 0 to 5, and columns ranging from A to E, and these are all the numerical values present in this data frame. So in this data frame that you can see that if I just want to check out the mean of A, so if I put it here, it says 1.8. So this includes 1, 2, 3, 4, 5. There are 6 values, one value is NN. If we take summation of all these values, then it comes as 5, 6, 7, 8, 9. So 9 by 5 is coming as 1.8. So this value is totally excluded from the computation of mean. We are not thinking that this is 6 values, we are thinking that this is just 5 values. So this mean is coming as 1.8. Now we are trying to impute the mean. So first of all, let us see, this is the df finally that looks. Now there is a very simple function. I will simply use that function in its indigenous way, like drop na, df dot drop na. And as we use this function, we see that a b c d e, these columns are present, and then some rows has been deleted, that is 1, and then 2, and then 4. So this index has been deleted, and the remaining are 0, 3, and 5, because 1, 2, and 4, they had NaN values in between them. So these are deleted by default. We can use in place equal to true to keep this as a permanent effect. If you put here INPLACE is equal to true, it is going to have the permanent effect in the data frame. But since we did not use in place is equal to true, our computation results are only temporary. If we check it out once again TF here, it is restored. Okay. So if we want to make it permanent, we use in place is equal to true. And now we have another way to look at this. Instead of drop NA, if I put AXIS equal to false, uh, axis is equal to, sorry, axis is equal to 1. So by default axis is equal to 0 was there. So if I put axis is equal to 0, it is going to bring the same result. But if I put axis is equal to 1, this is going to delete all those columns which has NaN. So A is having NaN, B is having NaN, C is having NaN, and E is also having NaN. So all these A, B, C, and E columns will be deleted, and we are left with D, which is having all the numerical values. So those column with the not having not a missing data will be retained. So that way you just saw here like how it works. Okay, so this you have learned like how to delete columns and rows which are having null values. Okay, so that is what you have understood. So now coming to the next point is filling the null values with some meaningful data. Suppose mean is the most meaningful data in a numerical value that can be used to fill the null values, and we can put df dot fill na and value is equal to df dot mean. So that way we can put it like this, and we have found that whatever was the missing value, you can see here, uh, 1 2 0 1 5, all these were the values, and this was the missing value in second one. So this value got filled with mean. So what was the mean? You remember mean was, we have already taken 1.8 was the mean earlier. So this 1.8 got filled up over here. Similarly for other things like here, these two values will be filled with the same mean value. And what will be that mean value? 5 plus 4 plus 7. So 5 plus 4 is 9 and 7 18. Okay, 9 and 7 16. 16 divided by 1 2 3 and 4. 16 divided by 4 is going to give 4. So this both missing values will be filled with value 4.0 4.0. So that's how you see that mean values are getting filled at all the missing values for that particular column. And this happens automatically using axis is equal to 1. So it happens column wise. In case you want to make it row wise, let me check if it is possible. I am not sure myself whether it will definitely be work. So let us put a x I s axis is equal to 0. So let us put, so we could do that also. Axis is equal to 0 is going to give us the same result. So axis is equal to 0 is going to give the same result. But if I put axis is equal to 1, it is going to give a different result, and probably it is giving some error. So we cannot have with axis is equal to 1. So this axis is equal to 1 is not applicable here. So let's have this for axis equal to 0 only, which is also the default one. So that's one learning for us from this live session. And this you can see here. And the next thing is df. So with this df, you can see. So let us see. I have not made any permanent effect to df, so it is still looking like this. In this df, now I am going to make permanent effect in some of the columns. For example, A, B, I want to fill with A, I want to fill with mean, and B, I want to fill with -1, and remaining I want to fill with very small value, say 0.001. So remaining I want to fill with very small value. So AB will be filled with respectively mean and -1, and remaining means C and E will be filled with very small value, that is 0.001, and in place is equal to true I am putting. So all this will be permanent effect in DF, and finally I will print DF. So you will see the result here. So if I put that, you can see this is 1.8, this is coming as mean, this is coming as -1. So that way I could fill this up with -1, and remaining is coming with very small value, that is 0.001 here and 0.001 here. So this all you could see. So whatever I wanted to fill the value with, it got filled up, and that way we can have multiple alternative in filling up the value. So this way you can understand like how to fill missing values. But the next question that arises here is when to go for suppose we want to take some measures like drop na axis is equal to 1 or drop na axis is equal to 0. Suppose I create this once again because this has been disrupted. So suppose I want to make this drop na axis is equal to 1, which is deleting columns, and axis is equal to 0, which is deleting rows. So when should we go for axis is equal to 0, and when we should go for axis is equal to 1, and in what circumstances we should do it the mass impact like value is equal to df dot mean, and in what circumstances we should go individual column wise update. And there are still more ways through which we can do it more precisely. So this is all a strategy based things in which we do the imputation of mean. So if there are very a small number of missing values in a very large set of data, maybe 1 lakh set of data is there, and many columns are also there. And in that data, if you find that some rows are having some maybe in 1 lakh data set, if 1 lakh rows, if 10-20 rows are there in which we have some missing values, maybe related to age or some gender or something, then we can simply delete the entire row and it won't impact much, right? Because we are anyway going to remove many outliers also. Sometimes some data comes with very extraordinary high or low value, so those entire row also we delete. So if we can delete some of the missing value related rows, it won't impact much in our model. So that's why we can delete them with this kind of statement like I have given this axis is equal to 0, drop n axis is equal to 0. In case there is a couple of columns and we can individually delete some columns, we cannot use axis is equal to 1, which is going to give a mass impact, because even if a single missing value is present in a column and because of that if you delete that column, it's something we are doing a big mistake. So if you are deleting any column, then we should have understood it well that there are 80% or 90% items in the column that are missing. So if some column is coming with 80-90% values of the 80-90% things as missing, and that cannot be generalized, then it is wise to delete that column itself. So that way that particular column can be deleted. And even if we are not deleting all these things, we can still impute values in a very generic basis like this, in which we put fill na value is equal to df dot mean, very generic imputation. And we can do very specific one like dfa dfb. Likewise column wise we can do imputation. And sometimes we can filter some columns based on some particular class like age range or salary range. Based on that we can filter some columns, and then in that particular class which is belonging to one salary class or which is belonging to one age class, we can do average on that particular class only. We will not do the average for the entire column, but for that particular class or for that particular cluster we can do that. So for cluster based or class based we can do some kind of imputation. So that is also highly appreciated. It takes time but it gives very nice formation of data which we can utilize later. Okay, so this is how you can see this, and this is all I have to say here. And